Hello, we are Benjamin Moreno and Alejandro Lopez from team number 12, and this is our eighth final delivery project. Our data came from Altos Hornos de Mexico, and the goal is to reduce the phosphorus contamination in steel. The independent variables that we have are the number of the furnace, the operator, the work shift, the group, the proportion of coke mineral, the temperature of arrival to zone 1, and the temperature of arrival to zone 2, their feeding speed, and the time that the furnace purges. For our scientific hypotheses, we have three statistical hypotheses. The scientific hypotheses are one, that the blast furnace purge time affects the phosphorus contamination. The second is that the temperature of arrival of each zone affects the phosphorus contamination. And the third one is that air feeding speed affects phosphorus contamination. Our statistical hypotheses are first, that the means of phosphorus contamination of each blast furnace per time are equal. And here we have the mathematical format with H0 and H1. Second, that the means of phosphorus contamination of each temperature of arrival to zone 2 are equal. Here we have H0 and H1. And third, that the means of phosphorus contamination of each air feed speed are equal. The distribution that our data follows is that of a normal distribution, sorry. And we selected that because we saw that in the QQ plots, the normal and the Weibull distribution are quite similar, but we think that there are less dots outside of the line in the normal distribution. We also selected that because phosphorus contamination is a percentage and is measured as a continuous variable. And the log likelihood values that we have are quite similar for Weibull and normal, but the test that we use place the normal distribution at the top because it makes several distribution tests.
Since we have normal distribution, we use the normal distribution function to obtain the maximum likelihood estimator using log likelihood. We we make the product of the likelihood of the function, sorry. Then we make the summation of the logarithms, transforming this product into summation. Then we apply the log likelihood and we obtain this formula. This is the formula that we are going to use to obtain these curve functions. For mu, we make the partial derivative of this function to obtain the function of the parameter, of mu parameter. And we did the same to obtain the function of the sigma parameter. And we obtain this and this result. Then applying maximum likelihood estimator, it's to equalize this part of the equation of the formula into 0, and with algebra we obtain that the mu estimator is equal to the summation of x over n, and the estimator of standard deviation or the variance is equal to the summation of x of each x minus mean to the power 2 over n. And in R, we obtain that the normal fitted parameters are 0.094 and 0.01 for mean and for standard deviation. Then we use the Cramer-Rowe formula, that is the variance of the estimated parameter is 1 over the Fisher estimator and the Fisher information, sorry. And we have that the Fisher information is this formula, and applying the second derivative to the formula presented before, we obtained that the Kramer-Roll lower bound formula is this value, and in R we obtain this value, that is 1.9585 for the Kramer-Roll lower bound, and this is the graphical representation of it.
We have for the validation approach that since our phosphorus contamination variable is follows a normal distribution, the prior will also follow a normal distribution. Our likelihood will be with a normal distribution and with no non-standard deviation, so our posterior will also follow normal distribution. The graphs that we obtain from the R software are this one. So we have the prior plotted as the black line, the likelihood plotted as the red dotted line, and the posterior plotted as the blue dotted line. To calculate a Jamestown estimator, since our data behaves normally, we use the following formula. And we use the code that we have here to obtain the mean of the Jamestown estimator, that is 0.103434. For the general linear model, we construct a general linear model based on the temperature of arrival to zone 2, air feeding speed, and purge time of the firmness. We use these three because since we have seen in all the other deliveries for this project, these are the ones that affect the most. So we use these three to construct our general linear model. And these are the results. We have on the left the real result, and on the right we have the prediction. And as we can see, it's quite a bit close. And we can see in the MSC that it's very small, which is good. But in our R-square score, we have that it's not very high. It's not close to 1. But this doesn't mean that our model isn't good. It's just that it doesn't describe the whole variance of the real data.
For hypothesis testing, we select to do a t-test for all these samples because we are comparing samples, and we use this apart from the all data that presented before. For example, for hypothesis number 1 that says that the means of phosphorus contamination of each blast furnace purge time are equal, we have a result of 90% confidence interval that includes the 0. That means that the null hypothesis is not rejected, so there's not true difference in phosphorus contamination means for each purge time. And graphically, we can see it in the normal plot presented in the right section, and we can see that the dotted lines are the means for time 4 and for time 2 of phosphorus contamination, and they are very close. For the means of phosphorus contamination of temperature to arrival zone 2, we can see in the confidence interval that 0 is not present there. So the null hypothesis is rejected. So there's a true difference in phosphorus contamination means of each temperature. And graphically, we can see that the means of each sample are very separate from each other. So this null hypothesis is rejected. And the third statistical hypothesis that we work with is that the means of phosphorus contamination of each air feed speed are equal. And in the 95% confidence interval, we can see that the 0 is included in that interval. And graphically, we can see that the means are close to each other. So null hypothesis is not rejected, and there's not a true difference in phosphorus contamination means of each air feed speed. And that's all. Thank you for your attention.